Hello there, this is Alana Tucky, and I received a question about this problem, which is 3.2, number 45, if you look in the top right corner. This is a long one, so I'm going to try my best to fit it into one video, but if not, it'll be two. Okay, so I'm going to click on View an Example. Let me make this larger here. And we have the data set represents the annual rate of return of 8 randomly selected bond mutual funds, and the data set below on the right represents the annual rate of return in percent of 8 randomly selected stock mutual funds. Use the information in the table below to complete parts A through E. So it's a long one. Okay, so I don't really need Excel, but I'm going to use it just to kind of be my typing machine. So you can do this on paper. You don't have to do this in Excel. Okay, so what I need to know is I need to know the mean and eventually the standard deviation of both of these data sets. As a matter of fact, I'm going to put right in here. This is the bonds and this is the stocks. And again, you do not have to use Excel. This is just me typing because I don't have a piece of paper to write on. So you could write this on a piece of paper. Okay, so what we need to know is we need to know the mean right here, and we need to know the standard deviation. Okay, so I'm going to grab a calculator, and I'm going to quit out of this, and then I'm going to clear stat number 1 for edit, and I'm going to go up, press clear, enter, and I'm going to type in the numbers for both of those data sets. So 1.7, 2.3, and so on. I don't want to make you watch that, so I'll pause and I'll be right back with all that typed in. There we have it right there. Okay, so I have my numbers. I want to press stat. Oops, let me make this so you can see it here. Stat, then I move to the right to calculate. Pick number 1, one variable stat. I'm going to start with L1, that'll be the bonds, and I'll go down to calculate. Make sure your frequency list is blank here. And there we have it. The average was 2.4125, and since this was a sample, then I want S, which is 0.719995, so 0.72. So let me write all that up, and I'll be right back. Okay, so it's typed right here. And then I want to do it again, but for the other data set, for the stocks. So I press Stat, move to the right to calculate, pick number 1, and I'm going to say second 2, so that's L2. Go down to calculate and press enter. And then there's the standard deviation 1.08, 1.081, and 8.275 is the mean. So you can see I already put those numbers right in there. Okay, so that's part A all done. So we've got the means, we've got the standard deviations, they're just like what we said. Now, based on the standard deviation, let me bring this back, which data set has more spread? Well, the data set with more spread will be the one with a larger standard deviation. So this was part A right here. Then part B, more spread, question mark. That would be the stocks, right? Stocks have more spread because the standard deviation is larger. Remember that standard deviation is a measure of spread. So the set with the bigger standard deviation has the bigger spread. All right, part C, I believe, wants you to find the coefficient of variation. Let me go back. So standard deviation, okay. Oh, to find the proportion, got it. So they want to know what proportion of each data set lies within one standard deviation of the mean. Okay, so we need to find the mean and the standard deviation. Okay, so first of all, I'm going to find the lower end, and then I'm going to find the upper end. And you could do this with, your calculator, with your paper and pencil. It doesn't matter. I'm just using Excel because it's convenient for me to be typing in. All right, so you want the mean within one standard deviation, right? So you want to know the lower end and the upper end. So I want 2.413 take away 0.720. Now I made Excel do it there, but you can do it in the calculator just as easily. You could say 2.413 take away 0.72, enter, and you get 1.693, which is what I just got there. Then you do the upper end, which is the same idea. It's 2.413 plus 0.72. There's your upper end. So you want to know what number of scores, what percentage of scores lie between 1.693 and 3.133. And actually, if I was going to be crafty about it, I could actually make Excel do it for me because I'm sneaky like that. So this cell plus this cell Later on in projects, that might be helpful for you, but you could use your calculator. It doesn't matter. And then I want to do the same thing with the other two numbers as well. So I would take 8.275, take away 0. Oh, rats, what was it? Take away 1.081. Take away 1.081. And then 8.275. Oops, 8.275, sorry, plus 1.081. There's the other number, 9.356. So 7.194 and 9.356. And again, I rather craftily got Excel to do it for me, but you could do it with your calculator and type it in, no matter. All right, so now what I need to know is what percentage of these scores are between these numbers. So if you are in Excel, you can actually sort it for yourself and make it kind of go a little bit easier, right? I can do it to both of them, sort. But if you're just doing it on paper and pencil, don't worry about it. You can just mark off. You want to know which numbers are between 1.69 and 3.13. So that's these ones right here. So let me highlight them. Okay, so those ones right there. And then between 7.19, 7's not in there. 7.8 is there. To 9.356, that's these ones right there. I'll give them a different color. There we go. Now, keep in mind, again, 7's not there. 7's below 7.19, so that's no good. You want to know what percentage are between them. All right, do you want to know percentage or how many? Hold on, let me go back. Proportion. So we want to know what proportion lie between there. So we have 8 scores altogether. 5 of them lie between. So this would be 5 divided by 8, so 0.725. So proportion between would be 5/8 for the blue, because there's 5 there out of 8 total. For the green, it would be also 5/8 because there's 5 there that are between 7.19 and 9.356. So in this instance, it's also 5 divided by 8 because there's 5 green ones out of 8 total. All right, so that's part C. Then for part D, they want us to find the CV, the coefficient of variation, which is your standard deviation divided by your mean. As I recall, that's what they want you to find. See, 5/8 for both of those. Yeah, standard deviation divided by the mean. So again, you could use your calculator. If you're working in Excel, you could use Excel, but you want to know this number, 0.72, divided by this number, 2.413. And again, I can use my calculator. So 0.72 divided by 2.413, 0.298. Then I do it for the other one, which would be 1.081 divided by 8.275. So 0.131. There we go. So there's the CVs for the two of them. And again, I'm being crafty and using Excel. You can use Excel if you're at home. Nothing's stopping you. But you could also use the calculator, right? Very simply. Okay, now we know the CVs. What do they want to know about that? So we found 0.298. We found 0.3131. Great. The CV is another measure of spread. So based on the CV, who has more spread? So bonds have more spread based on the CV being larger for that data set. So it's very interesting because this part B says stocks have more spread because the standard deviation is bigger. Part D said bonds have more spread because the CV is bigger, which is kind of getting at the fact that there's actually more than one measure of spread. There's actually lots of them. You guys already know about range, and now you know about standard deviation. You know about variance. That's 3 measures of spread right there. And CV is another measure of spread that you've just kind of glanced on this problem. And then there's another one coming, which is called IQR. And that's another measure of spread. So there's lots of different measures of spread, and there are more besides those anyway. All right, so in the table below, the data set on the left has the heights of students measured in inches, while the data set on the right has the same number of students' heights measured in centimeters. For each data set, determine the mean and standard deviation, draw a conclusion about the spread using the standard deviation, then find the coefficient of variation for both data sets. So that has us doing the same thing. So, okay, we can do it again. So let me I'm going to copy to my clipboard. Again, you do not have to use Excel. Paper and pencil will work just fine. Okay, so here's what were these heights? I gotta look it up. heights and inches and heights in centimeters. All right, so let me grab this. Let me type this up 1 second. Okay, so I go back to the calculator, stat, number 1, edit, go up and press clear, enter, go up and press clear, enter, and then I'm going to have to type in these numbers, 65, 78. All right, I'm going to pause because the next one's going to take me a minute, so I'll be right back with the next numbers typed in. All right, so there they are. And then I hit stat, calculate one variable. I'll say L1, second 1, go down to calculate, enter. There we go, 69.25 and 4.8. And then I would do it again, stat, calculate one variable, L2, second 2, go down to calculate, enter. And I get 175.895 and 13.075. And I already had all those calculated from Excel, but there you go. In case you're interested to know, Excel finds mean with the average. So I say average of those cells, and it finds standard deviation with stdev.s, in case you're interested. All right, so again, which has the more spread? It's got to be the heights in centimeters. So heights, let me copy that 1 second. Okay, so there's that. And then they want to know, let me go back to the problem here, because I don't think they want us to do the between part. Oh, they want us to find the CVs then for each one and then keep going. Okay, so we'll find the CVs. So we kind of skip over that whole part C part with the interval part, and then we're just going to kind of go right away to the CV. What they're trying to get you to see here is that the whole, wait a second, how do you have it so that standard deviation is bigger but not the CV? That's something interesting. But these are supposed to be the heights of the same people. So how is it possible that the heights or the CVs are different? That's a good question. So I take 5.418 and I divide it by 69, and I get 0.074. And again, you can use your calculator. 5.418 divided by 69, was it 69 point something? 0.25. And you get 0.074. And then for the other one, it'd be 13.075 divided by 178.895. Oopsie. 13.075 divided by, there we go, 178.895. There we go. I typed that wrong. Sorry about that. And you get 0.073. Hold on. Oh, I typed it wrong again. I'm losing my mind. 13.075. There we go. 13.075 divided by 175.895. There we go. Now we're getting it. Okay, so then it should be 0.0743. And then I had a mistake here in Excel, but it's all 6 now. So it's 13.075 divided by 175. And again, that gives me the same answer. So get it with your calculator, get it with Excel. Doesn't matter which one. So now, what's the difference between the two? And the answer is there really isn't a difference. The heights in centimeters and inches have the same spread because the CVs are equal, the coefficient of variation. So this is showing you this whole example that coefficient of variation is actually a very good measure of spread. It's not a measure that we use very often in our course, but it's often better than the standard deviation by itself because it's more accurate. Okay? All right, so, and notice that these two were basically the same number. That's why I said they were basically the same. If I round them to like 3 decimal places, there you go, you can see. Okay, so I think that's everything we need for that problem. We're all good. Yep, just saying that the coefficient of variation is unchanged there, which it makes sense that it would be. These people are the same height, whether it's inches or centimeters. Why should they have any different spread? And the answer is they don't. All right, I'll see you back here for more tutorials. I hope that helps.